Welcome to today's Software AG webcast titled 2017 Natural zIIP Enabler Webinar. Today's webcast will be presented by Patrick Gould, Chief IT Architect, Adabas Natural Pre Sales at Software AG. As we move through today's presentation, I invite you to submit any questions that you may have via the Q&A box, which is located in the lower right corner of your WebEx session. We will do our best to answer all of your questions. In the event that we're not able to answer your question, your submission will be recorded, and today's presenter will be back in touch with you as soon as possible. Additionally, today's presentation is being recorded. This recording will be available to you via YouTube should you wish to access it later on. To receive a copy of the YouTube link, please send an email to the webcast host. Before I turn today's presentation over to Patrick, I would like to briefly introduce you to Software AG. Software AG offers the first end-to-end digital business platform based on open standards with integration, process management, adaptive application development, real-time analytics, and IT portfolio management as core building blocks to help customers build their digital futures today. With over 45 years of customer-centric innovation, Software AG is ranked as a leader in many innovative and digital technology categories. Software AG has more than 4,300 employees and is active in 70 countries. It is now my pleasure to welcome Patrick Gould.
Good day, everybody. Hope you're all doing well. I think I know most of you out there. I looked at the list of the people that have registered. So hi to you all. As Will said, we're going to cover the Natural zIIP Enabler today. As you can see, it changed its name from the zIIP Enabler for Natural to the Natural zIIP Enabler. So a bit of word moving there, but it's better, faster, and does more. So hence the change. And that's sitting right next to our new Apple 7 stickers. So that's a little sticker that we placed on the web page, on the PowerPoint, and that's our 2050, our declaration that Natural Database will be supported, maintained, enhanced, innovated to 2050 and beyond. So part of today's webinar is to show you how the Natural zIIP Enabler fits into that go-to-market strategy. So just to give you a quick one slide on the Adabas Natural 2050 slide, we're talking about moving towards innovation, and then we have the three buckets of how we're going to get there. And those three buckets are optimize, transform, and modernize. And the highlights of those are mainframe zIIP offloading. And you'll see in our forecast, you'll see that we're actually moving towards getting Adabas zIIP offloader as well. We're going to be starting this year at seeing which pieces can happen. And so as we move forward, we will see more and more of the products making use of the IBM zIIP engine. The other part is we've improved product training. We now have really modern training for beginner natural database courses. They all can be run remotely. So you can actually get those young college students coming out of college and put them straight onto some modern training that is actually built within Natural One. And then transform, of course, is we want you to innovate, put all those business processes that you don't have available now with current systems, and allow those to interact with the ones you do, and have a digital business platform where you have all these APIs coming back into what you already have developed over the years. And then on the modernized side, we're moving towards a full DevOps operation with Natural One. So testing, moving, everything will be there, and then managed services. So that covers just the 2050 picture, and how I just wanted to do that to show you how the zIIP enabler, the Natural zIIP enabler fitted into that go-to-market strategy. So let's go back and touch history a little bit and see what the IBM specialty engines are and where they've come from and how far they've been around, how long they've been around. So the first one that introduced was way back in 1997, which is 20 years ago, and that was the internal coupling facility. And then as open platforms became more available, IBM moved in that direction, and they allowed one of the process engines, specialty engines, to be IFL. So that's the ability to run Linux up on the mainframe. Then with the introduction of WebSphere platform, XML, they introduced the zIIP, which is basically application automation process, I believe. And that was to enable some of the Java and the XML to be offloaded to a specialty engine which would not affect the MSUs that your machine was at. And now with 11 years already, we have the zIIP engines. And they have been designed to run eligible load, that which IBM allows, to run on the zIIP processor. The offload has to be switched on explicitly in the software's vendor code, so we have a special, they supply a special API, and we basically use the authorized services manager in Natural to be able to explicitly call that API and decide where the next block of code will run. So the API requires a license and agreement from IBM, which of course we have, and now have implemented that to allow all Natural to be zIIP enabled. So what does the zIIP enable allow you to do? It better enables more processes to run on the mainframe by offloading things like Java, XML, DB2, and then other workloads like SyncSort and Natural, in our case, to the zIIP engines. The zIIPs, when it comes to hardware planning, are attractively priced. So they're a lot cheaper than buying another GPP. You are limited to how many you can have based on how many GPPs you have, but there's enough to be purchased to allow you to offload and keep that MSU rating that you want on the mainframe and still do a lot more processing than you used to do. It is only available on ZOS and will always be available on zNext, which will, not this will, the other will loves to call the next IBM, he just calls it zNext. And then when we move to the software planning implications, of course, this cannot be IPO and cannot run operating systems. It's just there to run the SRBs, the service request blocks. Then the ZIIPs also allow customers to purchase additional power for eligible workload without affecting. And then, of course, the fact that ZIIPs reduce CPU on the GBP, that's going to both affect the total CPU you'll build on in a month, as well as lowering 4-hour average MSUs for machines. So that's important that we can now help you do that, and that is really the aim of this tool, is to reduce GBP CPU. This is a pretty cool graphic. It just shows you that if you have a GBP and you don't have a zIIP, everything will run on the GBP. If you do enable one of those zIIP processes on your mainframe, then you will have the ability to start reducing total cost of ownership. And we've seen hard-written customers have told us, we've actually seen the SMS data, we've seen the zIIP unload statistics that we have seen greater than 90 up to 98% of the Natural CPU running on the zIIP. So for us and for you, it's a quick win because there's no, it's a very easy product to install. It's basically license-based. The only software that has to be installed, and some people already have it installed, is the authorized service manager with Natural. So that's just another starter task that you need to set up. And that is the piece of magic that will see you have a license and will then allow us to switch between the two processes based on the different workloads. In some cases, we've seen some customers very early on saving about $150,000 a month, which clearly means we charge them too little, but we're happy they're saving all this money. We keep our customers around, we keep our customers happy. So then the biggest part is no changes to application code required. This is just infrastructure software, and basically the machine does the work for you about as to what needs to be switched and what can be switched. And which another good factor is we can handle peaks in workload with existing capacity. So for anybody who reaches their capacity at certain points in the month and would like to lower that, this is a good tool for doing that exact thing. So this is a little graphic that we could basically show and would look similar for any customer running Natural. And the aim is to show you when the peak comes, it's a combination of different processes, right? It could be CICS, it could be overhead on the machine, but we've got the little natural peak up at the top there. In this particular case, it's Natural Online, so this would be a user that is using more online than batch per se, and it's the one that peaks, gets the rolling 4-hour average gold star every month. But you can see if we can reduce that CPU of the Natural Online to a certain point, we can drop that peak significantly, like up to 40%. So when we say Natural can offload up to 90%, that's what it's going to do, but that doesn't mean your whole machine drops 90%. That means that your peak will drop to the levels of the other software running on the machines. And it's also going to give you the ability to try and maybe spread your workload if you can. Then you can maybe widen that out, especially the grayed area down the bottom. If you could spread that out a little bit, or the pink, spread it out a little bit, if feasible, you could really bring down your CPU a lot. Just to give you a little graphic of how it actually works when you have the authorized service manager running. The concept behind it is we will run on zIIP whenever possible. That has a caveat too, because if the zIIP is busy and there is zIIP to run on it, it cannot run. You cannot control how much stuff goes towards the zIIP at any point in time, other than not running that job that could get to the zIIP. So, but basically, when you have a GPP engine and a zIIP engine, we will start in SRB mode, and then we will switch to TCB mode when we cannot run on the zIIP engine. And then it's chunks. If we're doing I/O, it's running on the GPP. If it's doing calculations or normal processing of manipulating data, once it's received the data, that will all run on the zIIP engine. And basically, it switches backwards and forwards just based on the flow of your program and how it has been coded up. So, available now, which wasn't available before, we now have the zIIP enabler this month available on CICS. I'll show you the roadmap exactly, but this is the month that the CICS Natural zIIP enabler for CICS becomes available. So at a high level, when we talk about the Natural zIIP enabler, we see it as a great tool for customers with a significant scope of Natural workload on z/OS. And our aim is to allow you to reduce those peak loads for the GPP CPU consumption. And when we talk about what we can do on the Natural batch side, which was the first one we reduced back 4 years ago, is any Natural batch, any Natural RPC ACI server that runs as a batch process would see benefit from the zIIP unloader, Natural zIIP unloader, and would likely see significant drops in CPU. Now we've introduced online processing for Natural Com-Plete. That was late last year, and now in this month, April, we have introduced Natural CICS. And when we look at some customer successes of the natural batch, we've seen up to 98%. And then with some ECRs, early customer releases, we've seen about 80% of the natural online workload being offloaded to the zIIP. So this is the zIIP enabler roadmap. As probably a month ago, I was in training in Germany about 3 weeks ago to get all the scoop of natural zIIP. So it was first introduced in 2012 as known as the natural zIIP enabler for batch, and it included all the Adabas client components. Now moving into 2016 R&D, we're looking at different ways we could work with the online natural, and in 2016 the natural zIIP enabler for Com-Plete was introduced. And then right now, April 2017, and we know how that all works, it'll probably be the 30th of April, if that's a weekday, that the natural zIIP enabler for CICS will be officially released. It's been in ECR for quite a while now, and it will also include all the Adabas client components. And I have a graphic to show you what I mean by the Adabas client components for those who don't know. And then in October of this year, we'll make sure that we have to enable all the Adabas client components for natural under Com-Plete. And then, as I spoke earlier, the good news is we're starting to investigate feasibility and effort for natural zIIP enabler. And I know Dave Tipler is already at his drawing board, and he's creating all these fancy schematics on how this is going to be done. And the point is, in October, they hope to have an implementation decision and timeline depending on the results of the investigation. So that is all good news. So the thing that we have, the 3 different natural zIIP enablers per se, in essence, they all do the same thing, but this would sort of be the walkthrough you would have in a natural batch session, going through ADA user, ADA run. If you had any review exits, then any of the FastPath, Database Transaction Manager, Database Vista products, those all have been client-enabled for the zIIP processor. So we end up doing the minimum amount of switches that are physically possible when we go through this process for getting to the database data. So that is all fine-tuned, and we have, as you know, we have the quick start guide. There's all the ways to make sure that all of these products are installed correctly. You can run a test. We have little sample programs that you can run just to make sure that you've configured your natural and database environments correctly to maximize the offload. And then, of course, any customer exits that you have, those are similar to just your natural program itself, which is customer written. When we talk about the CICS natural, that of course is going to go through ADA LNC. Again, we're going to have the review exit, the core products, which are AFP, ATM, AVI, through to the router, some of those exits, and then lastly, the Com-Plete. So natural under Com-Plete will go through the TLOP user, the TLOP ADA, and then of course the ADA module there is the ADA LCO, the link module there. Again, the 3 products, FastPath, ATM, and AVI are client enabled over there. So I guess what you're all trying to say is, can you save CPU? And the answer is yes. These are the caveats. You've got to have a zIIP processor, right? You're not going to save CPU with natural zIIP if you don't have a zIIP processor. The good news is, if you don't have a zIIP processor, you can still do a trial or a POC, because as long as the software is installed, it's going to tell you what could be offloaded. And then, of course, I'm going to talk a little later about how we look for the initial walkthrough with SMF data to actually determine how much natural you have compared to total CPU, which is always a real good indicator of whether we believe we're going to see a good return on investment here. So yeah, the processors, as we know, are on the machines already. They just need to be purchased at a price way lower than those of the GPPs, and then they're ready to use. Natural ZOS customers who have ROI in CPU reduction. So if you as a company are really trying to reduce your CPU, this is a proven tool already that can help you do that. Of course, if you're charged by IBM and other ISVs by the CPU second on a monthly basis, or by a rolling 4-hour CPU average. We've seen customers that have both. This concept where someone like a government outsourcing to its agencies will be charged by IBM, for example, on the rolling 4-hour average, and then they turn around and charge all the agencies on a CPU second monthly basis. So in the beginning, it might be a little bit of funny money because you save on the one side, you're not necessarily saving on the other side yet. But by the time it comes to refresh that IBM mainframe, you can start looking at potential lift reduction or stay where you are, etc. So that's when the other part of the saving comes into play. The other up thing about that is when one agency is saving money, they have the potential to build stuff that will add some more CPU to the mainframe. So it all works together. Then, of course, an outsourcer. So if you're outsourcing to many customers and you can now maybe offer a little benefit to your end users for CPU reduction, you might get a few more customers who are interested in outsourcing to you. So as I've always said, there's no people I've ever talked to that aren't happy to maybe reduce CPU expenses. The ability to defer an upgrade or the need to acquire a new mainframe or even maybe downsizing. So we're seeing that in certain cases, and this is what the zIIP engine allows you to do. And that's why it is such a great product. So our customers have actually prepaid IBM for CPU usage just to avoid those penalties if they do go over. And this should sort of maybe allow you to sleep a little better at night if you know you're way beyond that because you've implemented the zIIP engine with Natural. Anyone who has long batch windows and online windows that involve Natural should and will save CPU. And then, of course, we still have our customers where their workload is increasing year to year. So this will allow you to manage that increase a little bit better and to maybe manage upgrades, et cetera, with the fact that you're increasing your MFUs every year, year on year. So how do we, in the US, help you, the customer, see if zIIP Enabler is the tool for you? So what we have put in place is we work with Barry Merrill with MXG Software, and he created a query for us that basically runs through your SMF data, and that would be type 30s and type 70s, and comes out with a very, very informative report. If you own the MXG software already, the concept is Barry just sends you the query and you run it because there's no need for you to send your data to him if you own it. And then if you don't own it, then we're going to ask you to please collect the data for at least a month, and then we have a process to get that data FTP'd across to Barry. You can do that FTP yourself, and then he will run the report for you on our behalf. So there's no cost to you. That's something we do as to help people who don't own the MXG software to see and use the report. There's a little upside to that for Barry. He's actually pulled in a few customers from the fact that he started presenting them with an MXG software report. They see so much benefit in it that they actually have bought the software so that they can run the reports themselves, because there's more tuning and stuff that you can do just by looking through the reports themselves. So what we've done, we've just changed the report to make sure we can report on online and batch separately. So you can just be able to segregate to see where your savings are. We will then come back to you, present findings, and determine the ROI of natural CPU reduction. And that is something that is always different for each customer. So it's a work in progress with each customer as to fine-tune what the actual ROI is, when it will happen. So that is just the way things work these days, because it just becomes complex to see when you save something, yeah, how does it save things down the line? But in the end, it does save. So it's just mapping out that actual ROI. If it's looking good, we then say, well, we should do a trial and POC, because the other one is just looking at what potential there is. When you do a trial or POC, you can basically see exactly what is offloaded. And there are statistic reports available to see exactly what was offloaded. And then we execute the POC, analyze the results. We do a final report showing expected cost savings. And then another thing we've introduced is with our health checks that we in pre-sales do. And we do about, this year we're doing 20. So we have clocked in a lot of health checks. And just a little plug on the health checks. Anybody who wants a health check, remember they're free. And they're really there only to benefit you, to make sure your systems are running optimally. And then we will look for stuff like Natural ZIIP while we're there, or Optimizer Compiler, or FastTap is going to give you an ROI. So that is still ongoing, and it helps us and you a lot to know exactly what our customers are doing. So this is just a quick show you what the SMS data analysis gives you. So this is an older one that does not have the batch and online split yet, but that report is ready to go. So you can see down here, or if you look at the column B, third row in column B is 745. That means this particular report has 745 hours of data collected. And then what Barry is looking for is the batch natural prox, PGM equals. So whatever your batch PGM names are, he's searching for that and putting it into buckets. So what we have at the end of the report, when the report is finished, we're going to have a column here that's got total CPU time. Then just as a add-on, we did add Adabas to this report as well, because that will help us see if anybody is really running a significant Adabas load, if they would benefit from FastPath or anything like that, caching, etc. So we just keep that for our own case and use it to show it to customers when we do a health check report, etc., when we do the readout. This column over here, the CPU, NAT, T, and H, that is the amount of natural CPU that was used for the month. So in theory, to get the percentage of natural batch, in this case, compared to the total CPU, is just to divide the CPU NAT time by the CPU job time. And in this case, I think it was around about 20%. And if we can say 90% of 20%, we can drop your CPU by about 19%, somewhere around there, 18, 19%. So in this case, it was significant. The customer did end up purchasing the product. The other nice thing it gives you is the rolling 4-hour averages. So the first report over here is the 20 hours with the highest job 4-hour average. And that will compare the total CPU for the job 4-hour actions with the natural 4-hour average. And then as you go down the pipe, you'll see that the natural 4-hour average is pretty high in all of these. So at the 4-hour average, we're consuming a lot more than 20%. And that really is the important one. And then we also do it for Adabas, and then, but the one that's more important is, of course, the 20 hours with the highest job, because this is the one, this is the actual report line, 756 down to 740, 755 that IBM will bill you on for those rolling 4 hours. So the highest rolling 4-hour average in the month is what you would get billed on. Furthermore, another nice thing I've discovered is the report actually also produces a report of all the jobs that ran in the month and the total CPU they consumed, and then the total natural CPU they consumed. So you can see, like on line 20 or on line 13, here's a job that used 56,000 CPU seconds, and that was all natural CPU seconds. We can often help you tune some of your programs, or help you tell you which jobs are the best to test or do the zIIP trial with based on this particular report. Of course, the other thing we can do is we can create any graphs that you like in Excel or whatever, and then you can see the total batch versus the natural batch at 50% or different ratings we normally do, and then the total batch with savings. It's similar to the other picture we had earlier up, just going to visually show you what the CPU reduction could be if the zIIP enabler or natural zIIP enabler was in place. So this is the statistics you get if you set the right parameters on inside of natural. So when we talk about collecting this information in a batch process, this would be per natural batch session. This information will be collected and then reported on at the end. And this is software AG collecting this data. So what basically we're seeing in this particular sample here is shows you the number of GBPs attached to the LPAR. So in this case, it's 6. Then we'll see how many ZIIPs there are attached to this LPAR, and we'll see that that's only 1. But then we'll see that the normalization factor of the zIIP compared to the GBP is it's 10 times faster. So zIIP engines can be faster. A single zIIP engine can be a lot faster than a GPP. Then we move into the number of switches into TCB mode. So task control block, that's the number of switches to the task control block, which is the I/O portions of natural that cannot be zIIP enabled. So there were 7 of those. There was 1 SRB start, so we switched over to the SRB once. Then the total enclave CPU time, that includes the CPU time for both the TCB and SRB, comes to 8. Of that 8, if the natural zIIP was there, which it was, it says that the qualified zIIP CPU time was 4. And then we'll see down the bottom that there was no zIIP eligible that didn't run on the zIIP engine. So there was space on the zIIP engine, so it could be fully run on the zIIP engine. So the total enclave CPU time for the zIIP was 4. And 8 divided by 4 is going to give us 50% of the job or program or whatever ran on the zIIP engine. So this is just an example of what the kind of statistics you will see. When you do this, when you have the enabler inside of CICS or Com-Plete, this will be printed out at the end or shut down. There are ways to get the data out while it's running. We'll plug for Optimize. We have a product called Optimize, which will allow you to pull out some of these statistics while it is in progress. But this is basically how you would, if you're not doing your own SMF analysis. I mean, you can go back and look at the SMF data to see exactly how much ran on the zip processes after the fact for a day, for an hour, if you can get in there. But this just gives you the information straight after the run itself. So now we're going to talk about some customer experiences we've had here in the U.S. This product has spread around the world now, and we're seeing more and more people using this. It's helping one of our SEs out in Australia. We have the New Wales Police Department in Australia busy doing the proof of concept right now, and they are sending Barry off their data, and we're going to start the process. Then we had one big one in Massif in France, the big auto bank. They purchased zIIP Enabler in Q4 of 2016. So this is a product that does what it says it's going to do and is going to save you money. So this was the state of Minnesota that presented at our Innovation Worlds or Innovation Tours, as they're now known, a few times. So that's the state. They have two big systems called Maxis and Prism. And this, in this particular case, they were saving well over $150,000 a month in CPU cost. So to me, that's a lot of money. But it's great to see that happening, and that's our aim, is to work with you to try and find out what the ROI is and get to the best numbers available. This now is OTEC, state of California, so there's quite a couple of agencies out there. We started with CalSTRS, we're the first ones to do the POC for zIIP. That also helps us produce a customer reference, so you can find this on our website. It shows you the ROI and the reason it made such good sense. So this is a little reference click down here. So this reference click, I will get it to you. This is to an article written by Will Hyman, who's probably the lead product manager for zIIP, and this was actually put into an Mainframe periodical. So anybody who wants this link, let me know. I'm not going to go there now in case it disrupts the webinar, but on this link will take you to an article written by Will Hyman about the value of zIIP offloading. We are getting close to question time. So I do have a few closing remarks, and that's the fact is that Natural zIIP has proven itself already. It's been around since 2012, and it can definitely help you reduce mainframe CPU. So if that's something you're looking to do, I suggest you let us know. You should know how to get hold of us. Just send us an email, and we can maybe start the process and get the SMF data analyzed and start seeing what sort of benefits you would see from a zIIP enabler. So, as I said, we have successful worldwide implementations, and more are doing POCs right now. And as I just said, please contact us. I'm patrick.gould@softwareag.com, so just send me an email and I'll follow up and we'll get the process rolling. And then I did make a mistake. The previous slide is, this link is actually to this PDF. Sorry about that. So if you want the PDF, you move there. This link down over here is the link to Will Hyman's mainframe costs reduction. Very, very good article. So take time, read it. It'll enlighten you a little bit more than I hope I have. So that is the actual end of the webinar talking points. And I believe if you have posed any questions, we'll now spend some time trying to answer those questions. If we don't get to them today, we will then make sure that we get those out to you. So thank you for now, but I'm here to hopefully be able to answer any questions that you might have.
Great, Patrick, thank you. The first question we have, are there any types of batch natural jobs that cannot benefit from zip? Example, batch jobs that read-write multiple work files. Or do the GPP CPU savings outweigh the number of TCB switches and I/O always?
Not always, because we do have the ability with natural zip to do print caching and work file caching, and that is optimized to make sure that we can offload the most. Our aim is to reduce switches to the maximum. It is true that you might not see as much offloading, and it is true that you might, as an individual, decide that a particular job in a job stream is maybe not worth zip enabling, and then that's your choice to monitor. If you analyze your SMF data, etc., and you see that this job actually ran a little longer than the other one, you just have to say zip equals off for that particular job stream. So, yeah, I mean, if the job is just doing pure I/O and nothing else, that's probably not a good candidate for zip. But that means we're not forcing you to run everything on the zip engine.
Okay, the next question. We already own Natural Optimizer Compiler and Adabas FastPath. Will we still see a good percentage of CPU switched to the zip engine?
Yes, you most definitely will. One of our biggest customers has all of those products in play, had them in play before they purchased zip, and then after zip, they still saw an enormous amount of CPU reduction. So between the three products, FastPath, Natural Optimizer Compiler, and zip, they're probably saving the most CPU they possibly could. And all three work very, very well for them. Anybody else? Because most customers do have. I mean, if you're seeing, my rule of thumb is if you're seeing a benefit from Natural Optimizer Compiler, your chances of seeing a benefit from the zip enabler are very good.
Okay, the next question. Can we do a proof of concept or trial without owning a zip processor?
Yes, you can. The thing is, you're going to have to sign a trial agreement for that, and then we can supply you with the software. And then that little report that I showed you, the little black report, will still be produced, and it will show you the eligible zip CPU time that could not run on the zip. And that gives you the indication that if you had a zip, this is how much would have been offloaded. So yeah, we can definitely, we can still do the SMF data as well, and you can still do the proof of concept, and then you can turn that into part of the ROI calculation, is what is the zip processor going to cost me, etc. So we can do both at the same time.
The next question we have, can I control priority-wise what runs on the zip processor?
Unfortunately not. I think lots of people would, but that's the way the zip is designed. If you, for instance, had a DB2 process running at the same time your natural batch was running, you're going to compete for zip usage. So it might take a little bit of workload manager settings or helping to try and make sure the DB2 and the natural batch aren't running at the same time, or the natural online, if that can be done. Or the other option is just to buy another zip, right? So you're going to be able to see how much ran on the zip, how much could have run on the zip, and then again, it's going to be a calculation for you to decide if you want to get another zip engine or enable another zip engine.
Okay. The last question we currently have, how much does Natural Zip Enabler cost?
The hardest question of the day. There is a list price for zip and then there's discounts depending on how many of the components you buy. But in the end, it's we work with you to determine what the potential savings could be, and then we're going to negotiate a price that allows there to be the ROI you're looking for. So, as I say, every single customer has been different so far, so it's very hard to put a fixed price on there because we just don't know what it's going to do.
Okay. I have another question.
Run the test. Yes.
I apologize. The next one I have is, do I need Enabler installed before I use MXG to evaluate the potential?
No. MXG is just a tool written by Barry Merrill that is a SAS tool, and he takes the SMF data that you provide and he runs it through that SAS engine to create this report. If you own MXG, as I said earlier, he will send you the query, and then you're just going to run that against 1 month's worth of SMF data, the type 30s and type 70s. And the only things we need are the names of the natural processes, right? So for batch, everything that's PGM for your natural batch nucleuses on Com-Plete, we're going to need to know the names of the regions that are running Com-Plete, because we'll be looking for that name. And then for CICS, we need to know which of the CICS regions are natural.
Okay. That is all of the questions that we have. Patrick, I'd like to thank you very much for your time and for the presentation today. Thank you to everybody who has joined us on today's webcast. As Patrick did offer his email, if you do have additional questions, you can reach him at Patrick, P-A-T-R-I-C-K, .Gould, G-O-U-L-D, @softwareag.com. So with that, our program has ended. Enjoy the rest of your day. Thank you.
Thanks very much.